Okay. So we're all ready to start with questions. Does anyone have any questions relating to how the class will run for the rest of the semester, or how we'll operate for the rest of the semester? Everyone's good?
Will we be on on Zoom every Monday and every Wednesday?
I don't think it's going to be every Monday and every Wednesday. I'll say at least once a week. There's some topics you guys will need to see what I'm doing. For example, partial fraction will be one of them, right? Let me see if I take off my glasses. Yeah, I can see without my glasses. Cool. Partial fraction will be one of them. So when I teach partial fraction, I think we'll need to meet. If you cannot make it, I'm not going to force you to, but if I do decide to say, hey, we have to meet, then I think you guys have to meet because it's during your class time. So you should be available during your class time. Questions?
Professor, I also know we're a little behind. Are we going to be able to cover everything that you had planned for the semester?
Yes, because moving online, we go faster. I know that sounds weird, but generally online is faster. We're getting back days from spring break. I don't know if they will extend the semester. So that's a possibility. But no one suggested anything as yet. Well, I think we'll finish because we're gonna finish chapter 2 very shortly. You'll take your exam and then we'll move on.
Okay.
Any others? Okay.
Good
Yes.
morning, Professor. Good afternoon. I just wanted to ask real quickly, do you think your calculus course for the beginning of summer session 1, is that going to be online?
Good question. So I know some of you registered already for my calculus course. We're not sure, right? But if it doesn't run in person, it will be online.
Okay.
And at least if we know, we'll know by, I'll say, end of April what's happening. So it'll be better. I am preparing for it to be online. So let's put it that way. If you don't want to, I wouldn't drop it yet if you're not an online person. Wait and see, because sometimes you drop it if they decide for it to be in person, then the class may be filled and I can't help you.
Right.
On that note, you guys read your email that if you feel this is too stressful for you, you should drop the course and the college will give you a refund. Are you guys aware of this?
No.
Okay. Then I don't know if you should be aware of it. Too late. I'm now on YouTube. So I was told that if you want to drop because, for example, you don't have internet access, you don't have a computer, you didn't really sign up for this, which we all never signed up for this, right? That's why we did a face-to-face. That the college will probably reimburse you back your money. I'll have to read back that email to be certain of what's happening. So you have an option. Yeah. Any other question relating to how we will work, or just questions from homework, and then we'll talk a little bit about what we're supposed to be doing. Any homework question? I think I had an email from one of you. Did I?
I have one question homework.
Yes. Can you tell me?
Wait, I have to pull it up. I forgot.
I like your picture, Camila.
Thank you, Professor. Okay, so my homework question was x squared plus 1, and then we're doing long division, and inside goes x cubed plus 9.
Are you sure about that?
I think that's flipped. My bad.
Yeah. So I can look at that and tell why. Because if I give you a fraction, think of fraction, right? If I give you a fraction of 3 over 4, can you really do anything with that other than writing it as a decimal? And the answer is no, right? Because it's called a proper fraction. when the numerator power or the numerator is smaller than the denominator, you can't do anything. Automatically I looked on this and I knew because the power of the top is a 2, the power of the bottom is a 3, you can't do long division here. Okay? What would be more if I switch it around? So this is not the problem. I think your problem is x cubed plus 9 over x squared plus 1. This I can do because now this will go into that at least once. Right? X cubed can be divided by x squared. You follow?
Yeah.
Good.
This is correct.
So now, to do long division, you want to make sure that you write all the missing terms. So if you notice here, the x squared term is missing. The x term is missing. So I'm going to rewrite this as x cubed plus 0x squared plus 0x plus 9. Okay? And then the denominator, the same thing. The highest power is a square, so we have x squared plus 0x plus 1. So what we're doing there is just filling in the placeholders. Okay? And now we divide. So we make our little division box. I have to be careful because I know the camera can't see the whole board. So on the outside we write x squared plus 0x plus 1. On the inside, x cubed plus 0x squared plus 0x plus 9. And long division really flows by itself. What do I mean by that? All you need to do is see always the first term with the first term. What do I mean by that? What is x cubed divided by x squared?
X.
Just x. So that's x. And I write that above the corresponding like terms, the x term. So that will be placed above the x term. Okay? Now I multiply. What is x times x squared? What is x times x squared? That becomes x cubed. What is x times 0x? Well, 0x squared. Right? X times x is x squared. And what is x times 1? That's just plus x. Now remember in long division, you're supposed to subtract all of this, right? So the signs of each one of these things will be its opposite. Take out that from here. So what is 0x? Remember the sign has changed. So this is now like a minus, this is a minus, and this becomes a minus. Only because when you distribute, right? So 0x minus x becomes negative 1x. 0x squared minus x squared becomes minus x squared. Okay? And this will always cancel out. Immediately after you combine, you then bring down. So plus 9.
Wait, Professor, isn't 0x squared just 0?
0, yes. So 0 minus 0 is 0x squared. Okay? And then I do the same thing, repeat again. So now, what is x squared divided by, so minus 0x squared divided by x squared. That will just give me 0. Do you agree?
Yes.
The x squared will cancel. So minus 0. So we don't need to write 0x squared. We could have left that out. Right? So 0 times anything here will be 0. And if you combine, you're going to have minus x plus 9. So when you do the long division, x squared plus 1. You guys see the bottom here?
Yes.
Okay, let me bring it up a little. X squared plus 1 over x cubed plus 9 will be x plus, and then the remainder, which is minus x plus 9, over your divisor. In your case, your divisor was just x squared plus 1. So this will be your final answer. Sometimes they bring the negative out. Be careful, if you bring the negative out, then you probably need to change that if you factor it out properly.
Okay, thank you.
Okay. Any other homework question? Okay. So today what I want to talk a little bit about is zeros of a polynomial, and then something called the rational zero test. So the whole idea about zeros of a polynomial, okay? Zeros of a polynomial. Zeros, as we know, is the same as the solutions of the polynomial, okay? So when we talk about zeros, zeros are the same as the solutions. They're the same as the answer, or we can say they're the same as the x-intercept. Realistically, the x value of the x-intercept. Now, please keep in mind that if you have a zero, you can get the factor. Or, if you have a factor, you can get the zero. Okay? It's like if I tell you today's date, which should be what, the 25th? You can tell me what day it is, right? Or if I tell you that, I gotta give a different scenario, because if I just tell you today is Wednesday, you don't know the date of the month. Unless I say it's the third week Wednesday. So what do I mean here? Let's look at an example. If we have f of x, so this is an example I'm looking at. If I have f of x is x squared plus 7x plus 12, let's say, and I ask you to factor this, everyone should be able to factor this. So can you try factoring this for me, please?
Yes.
Try this in your notebook. X squared plus 7x plus 12. Let's try to factor this.
X plus 3x plus 4.
Okay, so if you did this correctly, you're right. You will get x plus 3 times x plus 4. Or vice versa. You could have said x plus 4 first. These are called factors. Okay? Now, if I ask you to solve this, right? So if I ask you to factor, this is where you would stop. Right? If the question had said to factor, that's it. But if I change that question and I now say solve, what you do is take every single factor and you set them equal to 0. So now we have x plus 3 is equal to 0, or x plus 4 is equal to 0. And if you solve here, you have x is equal to minus 3 and x is equal to minus 4. These here are called your zeros, or your answer, or your solution. So if I give you a 0, can you get back the factor? Suppose I tell you that a polynomial has zeros at 1 and 3, right? If a polynomial has zeros at 1 and 3, example, zeros at x equal 1 and x equal 3. Right? Those are two zeros I'm giving you. Can you tell me what are the factors of that polynomial? Try, anyone, help me.
It'd be x minus 1 times x minus 3.
Very good, right? How do you get that? If you subtract 1 on both sides, you get x minus 1 here. And if you subtract 3 on both sides, you get x minus 3 here. These are your factors. And if you have the factor, you can actually get the polynomial, because if you multiply these out, quote unquote, if you FOIL them out, you will get a polynomial, wouldn't you? So you have to see the link between factors, zeros, and polynomial. That's the first thing you have to do to understand this whole section about zeros of a polynomial, or how do you graph a polynomial. You have to see there is a big link between the factors, which you have been learning for years in other math classes, zeros, which we're talking about now, which is the same as the solution, so you've been learning about that also, and to see the link between them. Okay? So why do we need to know about the zeros of the polynomial? Why do we want to find zeros of the polynomial? Because our goal, just like how we're happening in this state that we're in now, what is the goal of this whole thing with the virus? Is to reduce it, right? Our goal here is to learn how to graph polynomial. And the zeros tells us where the graph touches or crosses the x-axis. That's what the zeros tells us. So realistically, they're points on the x-axis. And if you can find those, and you know the endpoint behavior, which we spoke about, right, in the last section, then you have more knowledge of what the graph looks like. So that's our goal today. Our goal today is to figure out, how can we find zeros? Well, notice that when it's a quadratic, you can factor it. Or if you don't know how to factor it, you could use the quadratic formula and you can find the zeros, and then from the zeros, you could find the factors. Okay? So quadratics are easy because we either factor them, quadratic formula, right? Let's write that down. For a quadratic, for quadratics, we can find the zeros, by 1, factoring, and then we solve. Or 2, we can use the quadratic formula. Or 3, we can do completing the square. Those are the things we know right now. Okay? Everyone knows the quadratic formula. So you can solve any quadratic. So if we are able to take any polynomial, a third degree polynomial or a fourth degree polynomial or a fifth degree polynomial, and we break it down to a quadratic, then I can solve it. What do we use to do that? We use something called the rational zero test. Or we use some way to get those, to guess the zeros them of the cubic, to guess 1, and then we break it down. Okay? So here is something else that I want to point out to you, sort of a review. Okay? Earlier we had an example where we said f of x is equal to x squared plus 7x plus 12. And we said from here, this is the problem we just did, the zeros are x equal minus 3 and x equal minus 4. This is the one we just erased from the board. What's the fastest way to tell me that these are really zeros? Is x equal 1 a 0 for this polynomial, yes or no? Anyone?
Can you repeat the question, Professor?
Earlier, we looked at the problem x squared plus 7x plus 12. Right? We just did this. We factored it and we solved it. And we saw that the zeros were x equal minus 3 and x equal minus 4, right? Because the factors, you said, I think Camelia said it, it was x plus 3 and x plus 4, correct?
Yes.
Good. So when we solve it, we got x equal minus 3 and x equals minus 4. Suppose I tell you, or I ask the question, is x, here's the question, is x equal 1 a solution or a 0? What's the fastest way to do this, or an easy way? Anyone, any ideas?
Plug it in as x and get, if you get y as 0, then that means it's a 0.
Very good. Very good, actually, yes. If you plug in f of, what is f of negative 3? Let's just try that. Right? What is f of negative 3? Well, this becomes negative 3 squared plus 7 times negative 3 plus 12, which becomes 9 minus 21 plus 12, right? Which becomes minus 12 plus 12, which is 0. So anytime you plug in a number into any polynomial, and you get 0, that number you plugged in is a 0 or is a solution to the polynomial.
Can you repeat that one more time?
If you have a polynomial, right? Any polynomial, could be linear, could be quadratic, could be cubic, could be any degree polynomial. And I'm asking you, I pick a number off the top of my head, 5. Is 5 a solution to the polynomial you're thinking? Then what you have to do is take 5 and plug it into the given polynomial. If your output after you simplify it is 0, then the number you blurt out, then it's a solution. Okay? Let's look at an example of this. Suppose I give you the polynomial. Let's say I give you the polynomial g of x is equal to x squared plus x plus 1. Here's a question. Is x equal 1 a 0?
No.
No. How did you, or what did you do to say no?
I did g of 1.
G of 1. Good. So the solution, one solution, would be, what is g of 1? G of 1 would be 1 squared plus 1 plus 1, which is equal to 3. Do you agree? It's equal to 3. For it to be a 0, it must be equal to 0. Do you follow? For this to be a 0, the answer you get when you plug it in has to be 0. No other number must be 0. Okay? That's the whole idea here. If it's equal to any other number other than a 0, it's not a 0. It's a point on the graph, but it's not a 0. Well, here is another way you could have done it. So this is probably the shortcut. Another way you could have done this is, can I take this off? Another way I could have done this is use synthetic division. We want to know, is x equal 1 a 0? Or a solution, right? Alternatively, what I could have done, I could have performed synthetic division. The solution, or the 0, goes here. So this is a 1. And the coefficients of the polynomial, this is a 1, that's a 1, and this is a 1, goes in here. Make sure that if they're a missing power, you have to put a placeholder, right? Well, let's play this. 1 plus nothing, there is nothing here. 1 plus nothing is 1. What is 1 times 1? So what I'm performing here is synthetic division. 1 times 1 is 1. If you add 1 and 1, you get 2. 1 times 2 is 2. If you add 1 and 2, you get 3. What number do you see there? Is it 0? If that's not 0, this is not a solution, period. So when you perform synthetic division, if that last number is not a 0, the number you perform synthetic division by is not a solution or a 0 also. Two ways you can do it.
I have a question.
Yes.
Why would we use that method since it's a longer method instead of just inputting the number into the equation?
You know what I'm saying?
So it's just I'm just showing you a different way.
Okay.
So if you think plugging in was sort of easier for you, which is what I'm kind of hearing, right, then use that method. I'm showing you either ways to go there or to get to that point. And give you alternatives. Any other questions? Questions? Okay. Sometimes you guys will have to yell at me, right? Because I can hardly, if you don't have a good connection, I can't hear. Okay. So, we see that, hey, it may work or we don't work. Okay? So, how about if I ask you to solve this problem? If I ask you to solve, my blue is dying. Solve, and I'm going to take one from the textbook. X cubed plus x plus 1. G of x is equal to x cubed plus x plus 1. Can we use the quadratic formula to solve this?
No,
Why not?
because it's a cube.
Good, Camille, you're on top of this. Right? You can only use the quadratic formula to solve quadratics, meaning the highest power has to be 2. Right? That's it. Can we factor this? Is there any GCF? If you look at it carefully, there is no GCF, right? So we're stuck. We're basically stuck. Now, if I could write this as 2 polynomial, one being linear, I don't know what will go in here, and one being quadratic, we don't know what's going to go in there, then I could use the quadratic formula to solve this one. Because if you multiply x times an x squared, you're going to get an x cubed. Okay? And that's what the rational zero test is really telling us. Well, so we're going to use a tool, a technique called the rational zero test. Now, keep in mind what it's called, rational zero test. The rational zero test only gives you rational zeros. So if your 0 is an irrational number, rational zero test will not work. Okay? And that will happen here. Okay? So let's look at this and see what's happening. So we're gonna try, we cannot, so note, as Camila said, we cannot use the quadratic formula. Since g of x is cubic. Quadratic formula only works when it's a quadratic, right? Highest power has to be 2. That's it. Okay? So, we're looking. And something I'm going to introduce to you now is called the rational zero test. So we're going to try the rational zero test. It's called a rational zero test. Okay? It's long, but at least it helps you. Okay? So let's look at this. I'm going to give you a minute to copy whatever you're copying. I need to erase it because my camera is only catching a piece of my whiteboard, not my full board. Any suggestions will be helpful in terms of how do I catch my whole board. I try to adjust as much as I can.
Maybe if you bring it more back.
I did. We're gonna upload this video so you guys will then tell me, what's going on. I'm only sharing it to you in my other class right now. So, can I take it off? Okay. So, rational zero test. Rational zero test. So this is a test. You may want to write this in your notes. This is a test where you are looking for possible rational zeros. It's a test where you're looking for possible rational zeros. Note, if the number is irrational, you wouldn't be able to use this test. And you wouldn't know until you're finished. Okay? So the rational zero test says, we usually write it as, if you look it up online, you're going to see P over Q, where P is the factors of the constant term, and Q is the factors of the leading coefficient. Okay? So in that problem we just had, okay, g of x equals x cubed plus x plus 1. Notice my constant term here. What is p? P would be equal to 1, and q would be equal to 1 also, right? 1. You agree with that? The constant term is 1. The leading coefficient happens to be 1. So we're looking for, this becomes 1 over 1. What are the factors of 1? Well, be careful. Yes, I see you giving me the finger.
Plus or minus 1.
Plus or minus 1, right? So you can't just say 1. It's plus or minus 1. Why plus or minus? Because if you take two negatives and you multiply it, you'll get a positive 1. Likewise, if you take two positive and you multiply it, you'll still get a positive 1. So for any time you figure out what the number is, just add a plus or a minus to it. Okay? Plus or minus 1. Now, what are all the different possibilities that you can generate from dividing plus or minus 1? Well, let's write them out just for the hell of it. So this could be equal to, let's take the positive, a positive 1 over a positive 1, right? Both of them being positive. Or I could have a positive 1 over a negative 1. Or I could have a negative 1 over a positive 1. Or I could have a negative 1 over a negative 1. Those are all my possibilities. Can't have any more. Well, no matter what you do, a positive 1 divided by a positive 1 is 1. A positive 1 divided by a negative 1 is negative 1. A negative divided by a positive is negative 1. And two negatives, when you divide them, become positive 1. So what am I getting from this? I'm only getting 1 or negative 1, right? Yes? So those are the only two I have. Now, here's my question, and you will be able to answer this question. Is 1 a 0? We just did this, right? If you plug 1 in here, do you get 0? Well, 1 cubed, what is g of 1? G of 1 would be 1 cubed plus 1 plus 1, which is equal to 3. So x equal 1 is not a solution. Well, it's not a 0. Okay? How about g of negative 1? What is g of negative 1? Well, this becomes negative 1 cubed plus a negative 1 plus 1, which is equal to minus 1 plus 1, which is equal to minus 1. So is that a 0? No, that's not a 0 either. Now, take you back to 1 or 2 classes ago. Okay? What's the parent function of g of x? Parent function for g of x is? Anyone want to tell me?
X cubed.
X cubed, very good. Okay? Parent function is x cubed. Now, you know what x cubed looks like, right? X cubed, let me do it over here. Let's take this off. X cubed what is the endpoint behavior of x cubed? What happens to the left and what happens to the right? Yeah, I see many of you are drawing in the air for me. That's good. But how about words? It falls to the left and rises to the right. Okay? What do we usually say as x approaches negative infinity? G of x, or x cubed, approaches negative infinity. I didn't give it a name, so that's why. And as x approaches positive infinity, x cubed is also approaching positive infinity. Now here, logically, right? If on this side I'm in the bottom and that side I'm in the top, do you think at some point I had to cross the x-axis? The only way I can get from the bottom to the top, I'm going to have to cross the x-axis at some point, right? So that means this function does have a 0. Right? So how come we didn't find it? Well, you know the answer. Because the test only works for rational numbers. It means that the 0 could have been square root of 2, an irrational number. Right? It has to be somewhere in there, but this test only tells me that it is not a rational number. Therefore, it's got to be rational. Because I know it has to cross the x-axis. So the 0 must be an irrational number here. You follow? So that's where we're going, right? How do you use it? So now we got to use a different tool for this one. A graphing utility will help us. A computer will solve this and round it to the decimal place what it is. Or we have talked about narrowing down an interval to see where or what that number is, where we can actually narrow down the interval. Is it between 0 and -1, right? And we'll talk a little bit more about that in this chapter also. Questions? Someone keep track of time because my phone is recording. What?
Wait, Professor, I have a question. So then it's not the 0 is not even 0, right?
No, 0 wouldn't be a 0 because 0 cubed is 0, plus 0 is 0, plus 1 is 1. So 0 is not a 0. X equals 0 is not a 0. Okay? Remember, 0 could be any number. When we say the zeros of a function, we're looking for where is the function hitting or crossing the x-axis. That's what we mean by 0. Right?
And is it possible to find it for this equation?
Not with our knowledge that we have right now. The answer is yes, but not with our knowledge. An algebraic tool will help us, right? I'm sure if you go and look at the cubic formula and you plug it in, that will help us. Or if you solve this using a computer software, you will obviously get it. Okay? So let's look at one of them where it's possible. Okay? So I'll take this off. Okay. The next one we'll look at is, let's try this one here. H of x. So find all zeros. H of x is equal to x cubed minus 4x squared minus x plus 4. Equation is x cubed minus 4x squared minus x plus 4. Degree of this polynomial is 3, so quadratic formula cannot work. Okay? So when I ask you to find the zeros, I'm really asking you to solve this, right? So we have to find a way to solve it. Any ideas? How do I go about solving this?
You try the rational zero test?
Well, that's what I'm going to do, but is there another way? It's possible.
Can you do long division or synthetic? Sorry, not long. Never mind.
How many terms does this polynomial have? Hint.
At minimum 3?
How many terms does this...
Oh, sorry. 4.
4. Good. If you have a polynomial with 4 terms, you can try factor by...
Christian said grouping.
Yes. Where is Christian? I didn't hear him.
He's on the chat.
Oh, okay. Sorry. Good. Thank you, Camilla. So, if you guys are chatting, I can't see you, okay? So, someone will have to blurt out what you're saying. Yes, Christian, you're 100% right. Very good. Okay? Excellent. So, you can try factor by grouping, right? I'm going to do it, but I was hoping that you've seen that. But I'm not going to, that's not my goal in this, because I want to do the rational zero test. But let's try factor by grouping. If we try factor, so try factor by grouping doesn't always work. Try factor by grouping. Okay? So break it in two. So the GCF on the first part is x squared. So that leaves me with x minus 4. And then you can factor out a minus 1, you will get x minus 4. This tells me factor by grouping is working because both my parentheses are the same. So factor by grouping is working for us in this case. So now we have x squared minus 1 times x minus 4. And x squared minus 1 we know is x minus 1 times x plus 1, right? And then plus x times x minus 4. So the factors for this, how many factors do we have here? How many factors do we have?
3.
3 factors.
At most 3 factors.
No. Don't say that. We have 3 factors. Okay? Remember the linear factorization theorem, which is in the notes, tells you that if a polynomial has degree n, you will have precisely n factors. We will have at most 3 solutions, right? We'll have, remember, difference. We'll have at most 3 solutions, but we would have precisely n, being 3 in this case, we're going to have 3 factors. Okay? Now, if you have the factors class, can you tell me the zeros? Yes? So if the factor here is x equal 1, what is the 0? The 0 here would be x is equal to 1. The 0 for this one here will be x is equal to minus 1. And the 0 here will be x is equal to 4. Is that true? How do you check see if it's true?
You can plug it in.
Plug it in. So h of 1 should give you 0. H of negative 1 should give you 0. And h of 4 should also give you 0. So let's just write that in the side for now, right? We're saying that we have x is equal to 1, x is equal to minus 1, and x is equal to 4. Those are my 3 solutions that I have. Well, are these considered to be rational numbers? Is 1 a rational number? Can you write 1 as a fraction? Yes, 1 over 1. Fraction, right? Can you write 4 as a fraction? 4 over 1. Okay? So these are rational numbers. Any integer, guys, or class, it is a rational number, right? Okay? So that means if I use the rational zero test, I should get the same answer. Now, if I had solved this, let's say, and I got square root of 2, then I wouldn't be able to do it. Okay? So, let's use the rational zero test. Okay? So, let's leave that there. Take off all of this. And what are possible rational zeros? Rational zeros. Well, it will be, this would be my P, and this here would be my Q, correct? So it'll be all the factors of, let me rewrite that. This will be my Q. So my rational zeros would be the factors of 4 over the factors of 1. Well, the factors of 4 divided by the factors of 1. What are the factors of 4? Factors of 4? Plus or minus 1. Plus or minus 2 plus or minus 4, right? Factors of 1 plus or minus 1. Okay? Now the question is, if you do all of these computation, what numbers will they produce? The list would be pretty long here if I write it out, which I'm going to have to for the first one. So let's start off by writing it out over here. Well, let's take the plus 1, right? I'm going to have positive 1 over positive 1. Or I'm going to have a positive 1 over a negative 1. Okay? Yes, unfortunately, you have to do it. Then we're done with the 1, let's go with a 2. A positive 2 over a positive 1, or a positive 2 over a negative 1. Or I'm going to have a positive 4 over a positive 1, or I'm going to have a negative 4 over a negative 1. So you can see I'm going to get either here, I could have a 1, I could have a negative 1, I could have a 2, or I could have a negative 2, I could have a 4, or I could have, this will also produce a positive, a negative 4. Where is my negative 4? I'm missing some of them. A negative 4 over a positive 1. Okay? Which will give me a negative 4. Or I could have a negative 4 over a negative 1. So I'm missing some of them here also, right? Each one should give me 4. I'm going to have here a negative 2 over a negative 1. Okay? So the list can be long, but no matter what you do, these are what it's produced. So there's 2 more here, there's 1 more here, there's also another one here. Okay? But those are my only choices. Now, Delilah.
Professor.
Yes.
I'm sorry. Are you on a laptop?
I'm talking to you from my iPad, but I'm recording on my iPhone.
Oh no, I was just gonna ask if you put the screen a little down because I can't see the numbers, but it's okay.
No, I could do that. Oops. But then you're gonna miss the top. Let me see. Yeah, that says.
There are stands. There's stands you could buy that like adjust, so you could put your iPad on it and then push it.
Yeah, I just bought that one with the mic system for my phone, $170. So I'm not buying one for my iPad again because I'm not getting reimbursed for this.
Okay.
But if it helps, actually would, because going back to what we're saying, right, my calculus course probably will run online. I have to be more up to date with this. Okay. Okay, so Delilah, remember before you asked me the question, why do I want to do synthetic division when I could plug it in, right? Remember that you asked me? So here is the reason why. Here is the reason why I think you have to know that. So if I ask you, is 1 a solution? Clearly you can plug it in, you can tell me yes or no. Right? Is x equal 1 a solution? Well, if we plug 1 in here, do we get 0? Can you try that for me? If you plug, what is h of 1? The answer is on the board.
Yeah, it's gonna be 0.
I know.
Oh yeah.
Right? I told you before x equal 1 was a solution. But it's okay, you're trying. So I'm going to leave this on the board. So here's the thing, right? Here is the thing. If I know that x equal 1 is a solution, and I perform synthetic division, taking the coefficients 1, -4, -1, and 4, right? Those are my coefficients. We usually just write 1 there. Okay? 1 plus 0 is 1. 1 times 1 is 1. -4 plus 1 is -3. 1 times -3 is -3. -1 plus -3 is -4. 1 times -4 is -4. And if I add them, I get 0. What does that 0 tell me? That x equal 1 is a solution. Pay attention now. It also tells me, remember, x equal 1, this tells x equal 1 is a 0. So if x equal 1 is a 0, what is the factor? What is the factor? If x equal 1 is a 0, what will be the factor?
X minus 1.
Therefore, x minus 1 is a factor. Do you agree with that? Okay? Guys, I cannot stress how important it is for you to know and see this very quickly. Okay? You have to be able to see this quickly. So, x minus 1 times, attention, over here the degree was a cubic. Every time you perform synthetic division, that degree will decrease by 1. So this becomes 1x squared minus 3x minus 4. You see where I'm getting that from? Because I did synthetic division, this polynomial decreased by a degree of 1. So rather than being a cubic, it now decreases to be a quadratic. Okay? Can you solve or can you factor quadratics if you have to?
Yes.
Sure you can. So notice that this can be factored, and if you factor this, you get x minus 1, which comes down. This becomes x minus 4 times x plus 1, isn't it? And these are your factors, right? These are your factors. If you have the factors, what are the zeros? X, so these are called your factors. The zeros will be x equal 1, x equal 4, or x equal minus 1. So by using the rational, well, by the way, before, is this answer the same as the answer we got before? Yep. So, summary, we use the rational 0 to basically identify one possible rational 0. And once we have identified that this is a 0, we know that what the factor of that is. And then we're able to bring the answer of the synthetic division becomes a polynomial. And that polynomial, quadratic, can be factored, so we have all the factors. That's the whole idea of the rational zeros. The rational 0 will give you a whole long list. It's possible that one of them is actually a solution. And then you perform synthetic division to break the degree down of the polynomial to a quadratic, something that you can easily manage. how to solve it.
Professor, I have a question.
Yes.
Is it possible that it can have 0 factors? Like, I mean, 0 zeros, like no zeros?
Yes. Yes.
So sometimes we may have to look, for example, like here, it was 1, 2, 3, 4.
Well,
Like, for example.
here are some things you should look at, right? If it's odd degree, you're guaranteed to have a 0. Because one end will be pointing down, one end will be pointing up. It has to cross that x-axis. If it's even, then there's a possibility that it's not. Possible. Okay?
So every time it's odd, there is at least 1.
You have to. Yes. Okay? So those are things you will look at. So that's where we are. So you guys have to be able to do this to find all the zeros of a polynomial. And once you learn how to find all the zeros, then we'll look at some other things such as asymptotes and so forth. Questions? Any questions? Okay. So the notes for this has been posted online. It's been online, I believe, for a couple of days now. I will probably just add this video too. I don't know if there was any videos. There was some video, but I don't think a video for rational zero tests. So I'll upload this video today. You guys have homework due, or you will have homework due for Monday. And on Monday, I think we can only meet once a week. Maybe Wednesday is probably better. If we have to meet twice, we will. And then if you guys need like individual help, send me an email. Maybe I can do a one-on-one Zoom. Hopefully, I don't like doing one-on-one meeting because there are other people in the class who may have the same challenge. So let me know what you want to do. Let me stop the phone so at least we can continue talking.